Let's consider this geometry problem, and it's asking us to partition the line segment from A to B so that it's in a 1:3 ratio. And on the surface, that's a pretty difficult little problem unless you have a great strategy to address it. And I have one. We'll talk about it in just a minute. The strategy is to find the slope between the 2 points. So I'm doing the delta y over delta x. So I'm doing y sub 2 minus y sub 1 on top and x sub 2 minus x sub 1 on the bottom. Ends up being 3 over 14. So that's delta y over delta x. That's the slope. So what we're going to do is we're going to do a fourth of this y value and a fourth of the x value. The reason we're doing a fourth is because when you have a 1:3 ratio, if you add those together, you get 4. So this first point P that we're going to find, that will be how we segment this AB into AP and PB so that it's in a 1:3 ratio, is going to be 1/4 of the way up. So 1/4 of the slope, basically. So 1 plus 3 is 4, and I'm using the 1 because of the 1 there. So I get 3/4 and 7/2. So if you take the x value on the A point, which is -2, and you add the 7/2 that you got here to that, you get 1.5. And then take the 5, which is the y value on the A point, and you add 3/4 from here to that, you get 5.75. So point P will partition AB so that it's in a 1:3 ratio. So this point P is 1.5 and 5.75. So point P is the point along this line segment that will partition that line segment in a 1:3 ratio. So review those steps. You may have to watch this video a couple times so that you see what we're doing. So we're adding to the x value the 1/4 of this x value here, which was 7/2. And to the A value, y value of 5, we're adding 3/4 from this right here to get 5.75. So point P is the point that segments that segment, portions that segment in a 1:3 ratio.